Hello everyone, I welcome you all to this 8th lecture of this course, that is on Lipid Nanotechnology. So in this lecture we are going to learn various lipid based carrier system and mainly liposomes and solid lipid nanoparticles, and also we are going to see various applications of lipid based nanoparticles. So first we will see what is phospholipids. So lipids are the major class of biomolecules that includes phospholipids, cholesterols and fatty acids. Okay. So lipids are amphiphilic in nature, that means it is having hydrophilic polar head and hydrophobic tail, that is non-polar. So these are the various lipid based carrier system, and this one is liposome, and this is solid lipid nanoparticles, and this is nanoemulsion, and this is Micelles. Okay. So in this lecture we are going to learn all these lipid based carrier system. So why we are using lipids as a nano carriers for drug delivery application? Because it is biocompatible and biodegradable, and it is having a high loading capacity, and it is also having another property like prolonged circulation and tumor accumulation. So let us see what is liposomes. So these liposomes are the smallest round structure, okay, and it is made by naturally non-toxic phospholipids and cholesterol, and again it can act like a very good drug carrier, and also it can carry even plasmids, nucleic acid and anything. So that is why it has a wide applications in drug delivery, and these liposomes are made up of natural lipids. So it is lower risk of toxicity, and it can carry even hydrophobic as well as hydrophilic drugs. So another important property of this liposome is their exterior lipid bilayer, which is chemically reactive, and using this property we can tag antibodies and we can target this liposome to the cancer cells specifically. And another important property is this liposomes size can be varied from 50 nanometer to 800 nanometer. So we can load more amount of drugs, anti-cancer drugs or any therapeutical molecule. And another important property is this lipid bilayer is transparent, so we can use the fluorescent nanoparticles, the fluorescent material, and we can use it also for various imaging and diagnostic applications. So let us see the types of liposomes. The first one is conventional liposomes, and next one is stealth. Okay, the stealth liposomes is like this liposome with polyethylene glycol. The surface of the liposomes will be covered with polyethylene glycol molecules, that is called as stealth technology, and it can escape from the reticuloendothelial system. And third one is targeted. So here we can add antibodies or specific ligands, so to target your liposome to the specific cell. Okay, that is called as targeted liposome. And fourth one is cationic liposomes. So here it will have the positive surface charge. So as you know that DNA as well as your cells are negatively charged, so these cationic liposomes can easily bind, and it can be useful for various drug delivery applications. And the types of liposomes can be classified based on the size as well as lamellarity. Okay. So the first one is multilamellar vesicles. So these are typically range in the size between 0.05 to 10 micrometer, and it is consist of multiple phospholipid bilayers. And next one is LUV, that is large unilamellar vesicles. So here the size is between 100 nanometer, 50 to 100 nanometer, okay, and it is also made up of single phospholipid bilayer. And the third one is small unilamellar vesicles, and here the size is between 25 to 50 nanometer, and here also it is made up of single phospholipid bilayer. Okay, and these SUVs are prepared from MLVs or LUVs, okay, by sonegation or extrusion method. And in all types of liposomes, hydrophobic drugs are usually localized within the phospholipid bilayer, and the hydrophilic drugs are usually encapsulated within the liposome cavity. Okay, so inside the liposome cavity we can load the hydrophilic drugs, and in the phospholipid bilayer we can load the hydrophobic drugs. And the size of liposomes are determined by the preparation methods. For example, if you are preparing by sonegation method, you will get SUV, that is smaller than 100 nanometer diameter liposomes, and if you are using this method extrusion, you will get LUV, and if you are using this evaporation method, you will get GUV, that is giant unilamellar vesicle, that is larger than 1 micrometer diameter. So depends on the preparation method, the size varies. So let us see the cellular uptake of different types of liposome, how the cells uptake these liposomes into the cells. Okay. So these are the conventional and cationic liposomes. So this will be taken by the clathrin coated particles and it will undergo a endocytosis process. So this will be uptaken by this endosome and this clathrin coated endosome will reach the lysosome and it will form a endolysosome. So there it will get degraded and it will release the drugs to the cytoplasm. In case of pH sensitive liposomes, so due to acidification of these endosomes, so it will release the drug to the cytoplasm, and if you are using the DNA cationic liposome complex, so it will bind to this cell membrane based on the electrostatic attraction, then the DNA will be diffused into the nucleus. And if you are using these sterically stabilized liposomes, so where you are adding this PEG for steric stability, and here it will release the free drug, and these free drugs can enter the cells by diffusion or it can enter the cells by pinocytosis, that is called as cell drinking process, and that will go to the cytoplasm and it can deliver the drugs to the cytoplasm. So let us see the advantages of liposomes. So it can load hydrophilic as well as hydrophobic drugs, and we can easily modify the surface by antibody or some other ligand so that we can target these liposomes, and it is having low antigenicity, that means highly biocompatible and highly biodegradable. And these liposomes can be prepared by several methods. So here I will be explaining some simple method, that is DRV method, okay, dehydrated and rehydrated vesicles. So how to make this? Here empty SUV liposomes will be lyophilized in presence of solution of the compound to be entrapped. If you want to entrap your drug or if you want to entrap the fluorescent particles, so that should be lyophilized in presence of SUV liposomes. So during rehydration, the addition of small volume of water results in liposome with high entrapment efficiency. Here the advantages are, it is a simple method and here we are using the mild conditions, so we can achieve high encapsulation efficiency for variety of compounds. So here you can see the DRB technique. So we can prepare the empty SUV and we can mix with the equal volume of solution or material which should be encapsulated within this SUV, and freeze dry, that is lyophilize. When you freeze dry until all the water has been removed, then you do the rehydrate in a controlled way. When you add a very low volume like 1:10 of volume, and it will give the very good small size SUV particle with drug loaded nanoparticles. So other methods are, you can use like detergent removal from mixed lipid detergent Micelles, so which leads to LUV with large encapsulation volume. And next method is freeze thaw sonegation method. So in this method you will be having repeated cycles of liposomes freeze thawing, which leads to formation of LUV with high encapsulation efficiency. So once you load the liposomes with your drug, then you have to purify. So how to purify that? You can follow centrifugation techniques and you can follow dialysis and gel filtration. So in this centrifugation technique, when you centrifuge your liposomes, okay, which is loaded with the fluorescent dye molecules, and you can remove the supernatant and your liposomal pellet will be at the bottom, and you have to add fresh buffer, and again you can repeat the centrifugation process. By this process you can get the purified liposomal suspension with your fluorescent nanoparticles or fluorescent dye molecules. And next method is dialysis. So here you can use this method for purification of all type of liposomes, and here we will be using the dialysis bag with the cutoff molecular weight cutoff of 10,000 Dalton, and when you add excess buffer solution, and you will be dialysing under stirring condition at 4 degree, and you have to replace the buffer every 4 to 5 hours until no fluorescent dye is detected. So when you do the dialysis, then you will get the only liposome particle loaded with fluorescent dye or fluorescent nanoparticle. Okay. The third method is column chromatographic separation. So here we will be using Cepadex G50, it is polydextran beads, and this molecular weight cutoff is 1000 Daltons. When you use this Cepadex column, you have to consider two important points, that is there may be a lower yield. Okay. So this problem can be overcome by making sure that the liposome sample size is not too small, or the column can be pre-saturated with the empty liposomes. Okay. And second thing is, larger liposomes of more than 0.4 micrometer may be retained in the column. Okay. So these are the problems with this Cephadx method, and these problems can be overcome by using medium or coarse grade of Cephadx beads. Okay. So, before we learn what is solid lipid nanoparticle, let us see some of the other types of lipid based nanomaterials, that is Niosomes. So, Niosomes are non-ionic surfactant vesicles, okay, and these are widely studied as an alternative to liposomes. So, here the Niosomes overcome the disadvantages associated with the liposomes. So, for example, chemical instability and variable purity of phospholipids and high cost. So, these are the drawbacks of liposomes. This can be overcome by the Niosomes. So, the preparation method and everything is same for Niosomes and liposomes. The only thing is it will be having non-ionic surfactant, and these Niosomes have enhanced penetration of the drugs, and also we can have the controlled and targeted drug delivery using these Niosomes. So, next carrier is Micelles. So, here we can have the self-assembling nano-sized collider particles with hydrophobic core and hydrophilic shell, and it is mainly used for solubilizing various poorly soluble pharmaceuticals. So, here you can see here this hydrophilic head is facing towards water and your hydrophobic tail is towards inside. So, it is in presence of water, and in presence of organic solvent it forms the reverse micelle, where the hydrophilic head will move towards inside and hydrophobic tail will be facing towards the outside towards the organic solvent. And another type of lipid based material is nanoemulsion. So, here we can achieve emulsion in nanometer scale. So, emulsion means it is a thermodynamically unstable system, consists of two least immiscible liquid phases. So, one of which is dispersed as globules, okay, and the other one is in the liquid phase, and these are stabilized by the presence of an emulsifying agent, that is called as nanoemulsion. So, let us see what is solid lipid nanoparticles. So, solid lipid nanoparticles are nanometer size particles with solid lipid matrix, okay. So, these are oily droplets of lipids which are solid at body temperature and it are stabilized by surfactants, and their production is relatively simple process where the liquid lipid oil in a nanoemulsion is exchanged by a solid lipids, okay, and this process does not require any organic solvent, and here we can get this SLN, that is solid lipid nanoparticles, spherical in shape, okay, and you will have the solid lipid core, and this core lipids can be made up of fatty acids or waxes, and the biological membrane lipids such as phospholipids can be utilized as a stabilizer, okay, and these solid lipid nanoparticles will be in the size of between 50 to 100 nanometer, and it will be remain solid at room temperature and body temperature, and this solid lipid matrix is useful for loading your hydrophobic drugs, okay, and this lipid matrix is stabilized by the biocompatible surfactants, and in this case we can use phospholipid or we can use a lipid PEG, that is polyethylene glycol, for stabilizing your solid lipid nanoparticles. And we can also incorporate hydrophilic drugs into this SLN using polymers. So, here you can use that negatively charged polymer and positively charged drug. So, it will combine and form this kind of complex, and when you mix with the solid lipid matrix and surfactant, so it will form this kind of structure. So, in this process the drug polymer complex are incorporated into the lipids for SLN preparation, and this strategy give rise to polymer lipid hybrid nanoparticle, that is PLN. So, there is another type of material, that is LPN. So, that we will see what is LPN. So, LPN is lipid-polymer hybrid nanoparticles. So, here this LPN exhibit a characters of both polymeric nanoparticle as well as liposomes, okay. So, it mainly consists three components. The first one is polymeric core, okay. So, the polymeric core is made up of your polymers like PLG or PLA, where your drug will be encapsulated, followed by you will be having a phospholipid layer, okay. So, that is surrounding your polymeric core, and which will prevent your encapsulated drug from leakage, okay. And you will be having another outer lipid PEG, so that is your stealth layer. So, if you are having a PEG in your outer layer, so that will make your nanoparticle to escape from the reticuloendothelial system, and that will increase your in vivo circulation time. So, how to make these solid lipid nanoparticles? Again we can use the top down approach and bottom up approach. So, top down approach is you can make from a bulk lipid, you can get the solid lipid nanoparticles, and bottom is from the lipid molecules you can get the solid lipid nanoparticles. Under the top down technology, these are the methods: high pressure homogenization, microfluidization and membrane contractor method. And under the bottom up you will be having emulsification, solvent evaporation and emulsification, solvent diffusion. So, out of these techniques, this high pressure homogenization and microfluidization are the most preferred ones, because it is easy to make, at the same time it is also industrially most feasible method. So, let us see the difference between the liposome and nanoemulsion and lipid nanoparticle. So, here in liposome the lipid bilayer enclosing a aqueous core, okay, here it is water. In nanoemulsion the lipid monolayer enclosing a liquid lipid core, and in case of lipid nanoparticle and solid lipid nanoparticle, so lipid monolayer enclosing a solid lipid core. Okay. So, what are the advantages of solid lipid nanoparticles when compared to the liposomes and lipid emulsions? So, here in drawback of liposomes are drug leakage, hydrolysis and particle growth and unstable during storage. And in case of liquid emulsions, same like drug leakage, hydrolysis and particle growth and unstable during storage in the lipid emulsions. But these drawbacks will be overcome using solid lipid nanoparticle. Here there is no drug leakage due to solid matrix, because we are having solid matrix in the core, so it will release the drug very slowly, and it is stable against hydrolysis of drug, and it is stable against the particle growth, and also it is having a solid core, so it will release the drug very slowly for prolonged time, and it is comparatively stable during storage. So, let us see the mode of delivery and drug release of SLN. So, here SLNs generally injected either intravenously or intramuscularly to target the organ. So, due to the small size, and it can be useful for the systemic body distribution with the minimized risk of blood clotting, okay. And SLN provide a sustained release of drug when it is administered subcutaneously. So, let us see the advantages over the conventional drug release systems. So, it combines the advantage of lipid emulsion as well as polymeric nanoparticle, and it also overcomes the temporal and in vivo stability, which is very important for any nanoparticle mediated drug delivery approaches. And again here we can load any hydrophilic and hydrophobic drug, and carrier is not toxic, and again we can have the control release of drug, and we can add antibody or anything to target the carrier. So, let us see what is nanostructured lipid carriers. So, this is also similar to solid lipid nanoparticles, but here the lipid particles have been developed by mixing solid lipids with the liquid lipids. So, when compared to this SLN, NLC have disordered structure, so which makes the matrix structure imperfect and creates spaces to accommodate active compound. So, here we can have like a high loading capacity and again long term stability when compared to this SLN. So, let us see the morphology of nanostructured lipid carriers and their improvements over SLNs. Here the nanostructured lipid carriers are lipid nanoparticles composed of solid lipid matrix immersed in liquid lipid droplets, okay. So, this solid lipid is used as a matrix to immobilize the drug, and it will prevent the particles from coalescing with one another, and also the liquid lipid increases the drug loading capacity. And here you can see the structure in solid lipid nanoparticle, it is almost perfect solid lipid matrix. In case of nanostructured lipid carrier, it is having imperfect lipid matrix consisting of solid and liquid lipids. So, due to this imperfect structure, okay, so we can have like a more drug loading capacity in the NLC, and also it will prevent the rapid drug release from the surface, which is one of the drawback of SLN. So, how we can use this nanotechnology for various liposome based carriers? So, the nano liposomes and nano Niosomes are mainly used in the cosmetic industry as delivery vehicles, and this SLN and NLC, it is also very good drug delivery agent when compared to the liposomes, and the NLC have been identified as a potential next generation cosmetic delivery agent, and which can provide enhanced skin hydration, bioavailability and stability of the agent. And the different routes of administration is possible using these lipid based carriers. So, it can be transdermal, intravenous or oral, or it can be intranasal delivery. So, these are the various applications of lipid based nanoparticles. Let us see one by one. First one is drug screening microarrays. Here solid lipid nanoparticles enable a simple method of surface mediated delivery of drugs to cells from a microarray of phospholipid multilayers, and which is encapsulating the small molecules. So, this SLN will be useful for identifying the suitable drug candidate in a shorter duration of time. And next one is for drug delivery application. So, this solid lipid nanoparticle based drug delivery system will be having a prolonged and controlled release of drug, and it can release the drug through diffusion or by membrane fusion, that we already explained in the mechanism part. And these liposomes can be useful for cancer therapy. So, usually in the tumor location that it will have leaky blood vessels. So, if your liposomes of size between 200 or more, so it can accumulate in the tumor location and it can deliver the drug, and which could be useful for cancer therapy. Next one is we can also use lipid based gene delivery agent. So, when you use a cationic lipid, that is with positive charge lipid, and you have the DNA which is having negatively charged, so it will combine and form a lipoplex, and this can attach to the cell, and through endocytosis process it can deliver the gene. So, we can use the lipid based nano carrier for gene therapy or gene delivery applications, and we can also use solid lipid nanoparticles for ocular drug delivery. Okay. So, this SLN will enhance the corneal absorption of drugs and improves the ocular bioavailability of both hydrophilic and lipophilic drugs. And another important advantage of this SLN is it will allow the sterilization process. So, which is a very necessary step towards formulation of any ocular preparations, and it can also act like a vehicle for your vaccination. So, usually the antigens are adsorbed on the surface or entrapped in the matrix of solid lipid nanoparticle, so which will induce the enhanced immunological response. Okay. And here the particles offer a prolonged and controlled presentation of the antigen to the immune system. So, this SLN based vaccine will have a very good protecting effect against the different kind of infections. So, the next application is topical drug delivery system. So, here you can see the difference between the free drug as well as liposomal drug, and the free drug it is entering through the skin and it is reaching the blood supply, which will induce the systemic toxicity. In case of liposomal drug, it will reduce the irritation and it will enhance the drug permeation, and also it will show prolonged residence time and it will reduce the systemic toxicity. So, you can see the difference. In free drug there are more amount of drug molecules are going into the blood, and here you can see that liposomal based drug delivery, it is control and slow release of your drug molecules. And we can also incorporate these lipid nanoparticles into new cosmetic products because it has a very good physical stability and compatibility with the other ingredients, and these lipid nanoparticles also patent protected worldwide as lipo pearls or nano pearls for various cosmetic applications. So, in cosmetic it will have an improved stability of chemically unstable ingredients, and also it will have a controlled release of active ingredients, and it will improve the skin hydration and protection through the film formation on the skin. So, another application is high end cosmetic ingredient. Okay. So, usually the UV rays in the sunlight, it will create thymine dimer formation in your DNA. So, you can see here this is TT bond, that is thymine dimer, it is a intra bond, and it will leads to damage the cell, and also it can cause skin cancer. So, when you have this T4N5 enzyme in liposome, so that will repair this thymine dimer damage in the DNA, and this T4N5 removes the thymine dimer and allows DNA replicated normally and it will restore the healthy skin conditions. So, the hydrophilicity and large molecular weight limits the permeation of T4N5, but when we encapsulate this T4N5 in the liposomes, it will enhance the skin permeation and greater amount of enzymes can be delivered and it can repair the damaged DNA. So, as a summary, in this lecture we have learnt various lipid based carrier systems and especially liposome and solid lipid based nanoparticles, and also we have learned various applications of lipid based nanoparticles. So, I will end my lecture here. I thank you all for listening. I will see you in another lecture.